Assalamu alaikum everyone. We're going to solve Cauchy-Euler's equation using the Cauchy-Euler's method, that is from exercise 10.4 mathematical methods book by SM Yusuf. So before doing this Cauchy-Euler's equation, you must know what Cauchy-Euler's equation is. Just a brief introduction and then we will move on to solving that example. General representation of a Cauchy-Euler's equation is xn dny over dxn plus xn minus 1 dn minus 1 y over dxn minus 1 plus up to x dy by dx, and finally here y equals to f of x. This is the general representation of the Cauchy-Euler's equation, or this can also be written as xn dn plus xn minus 1 dn minus 1 plus up to x square d square plus xd plus 1 times y equals to f of x. This general Cauchy-Euler's equation can be written in this form as well. Now, whenever you are given with this kind of equation, Cauchy-Euler's equation, like you can see this in question number 1, x square d square plus x d by dx plus 5y is equals to x5. This is Cauchy-Euler's equation. Now let's come what we are going to do if we are having a Cauchy-Euler's equation in our question. Our step 1 will include here a variable coefficient. We have to suppose here x is equals to e raised to power t. Always in every Cauchy-Euler's equation we are going to suppose that x equals e raised to power t. And xd, xd can be written as just delta. And delta is d by dt, derivative with respect to t. Or you can see x d by dx, and xd, you will take xd as delta, you will take x square d square as delta into delta minus 1, that is delta square minus delta. This delta is basically derivative with respect to t. And if you're given with x cube d cube, this is delta minus 1, delta minus 2, and you can expand it as well. And if you have x4 d4, you can write delta minus 1, delta minus 2, and delta minus 3, and you can expand it. This one is going to be our first step. After using this first step, you have to use all these identities in your question. After using all these identities, in our step 2, we have to find our complementary solution. In step 3, we have to find our particular solution. After finding complementary and particular solution, you have to find your general solution by adding up the complementary and the particular solution. And then after finding the general solution, you have to substitute back using this equation, back substitution. So let's discuss everything in this example. Question number 1 of exercise 10.4. And the name of the book is Mathematical Methods by SM Yusuf. So this is your Cauchy-Euler's equation, and this is x square d square x d and simple y. Step 1. In your step 1, you have to substitute x equals to e raised to power t, and you have to substitute x d by dx, that is your xd, as delta. You have to substitute x d square by dx square, that is your x square d square, as delta minus 1, and you know that this is delta square minus delta. So this is your equation number 1. Let's substitute all these values. So what I'm going to get here, equation 1 implies that x square d square is this, del square minus del, plus 7 times xd, xd is delta, plus 5 times this y, I have taken the y common from everything, equals to x raised to power 5 e raised to power t 5. Now let's expand it, simplify it. If I will simplify it, I'm going to get here del square plus 6 delta plus 5 y equals to e raised to power 5t. So this is our OD now, non-homogeneous differential equation. So our second step is going to be finding the complementary solution yc. So first of all, convert it into the associated equation. M square plus 6m plus 5 times y equals to 0. I am taking the homogeneous equation right now. Just factorize it. If I will factorize it, I will get here, there's no need to write the y. M will be minus 1 and minus 5. These will be two factors from this quadratic equation. So you see that these rules are distinct, different. So our complementary solution is going to be C1 e raised to power minus 1t plus C2 e raised to power minus 5t. Because our equation is now in t, I substituted this x in terms of t. Now our third step is going to be finding our particular solution. I am going to find here particular solution. For particular solution, you have to consider this non-homogeneous equation. So keep the y on the left side and move its coefficient on the right side. Del square plus 6 del plus 5 and e raised to power 5t. Now I'm going to factorize it. We are following the same method as we did in exercise 10.2. We did this method in detail in exercise 10.2. 1 over del plus 1, del plus 5, e raised to power 5t. Now you know that if you have exponent here, exponential, the coefficient of t will be replaced with del. So 1 over 5 plus 1 and 5 plus 5 e raised to power 5t. This will be simplified as e raised to power 5t over 60. So we got our complementary and we got our particular solution. So let's add them both to get the general solution. So our general solution is going to be y equals to yc plus yp, and substitute the values. Now you know that your question was in x, not in t. Your question was in x. So we have to use the back substitution of this thing to remove the t. How we can remove the t? Let's take the value of t out of here. Apply the ln natural log on both sides. Ln x equal ln e raised to power t. So ln x equals to, the power comes down, t ln of e. And you know that ln of e is 1. So the value of t comes to be ln of x. So let's use this value. In place of t, it's going to be ln of x. C1 e raised to power minus ln of x plus C2 e raised to power minus 5 ln x plus e 5 ln of x over 60. Now C1 e raised to power ln x minus 1, this can come in the power, plus C2 e raised to power ln x raised to power minus 5 plus e raised to power ln x raised to power 5 over 60. You know that ln and e are anti-process of each other, so they are going to cancel out like this. So we are left with here C1 x raised to power minus 1 plus C2 x raised to power minus 5 plus here x raised to power 5 over 60. So in this way you can solve the Cauchy-Euler's equation. And now after this video I am going to upload exercise 10.4 part 2. In exercise 10.4 part 2 by mathematical methods, we are going to discuss the rest of the questions that are depending on Cauchy-Euler's equation method. So for more updates, keep watching my channel and you have to subscribe it and kindly share it with others as well. Thank you so much.